folks. Okay, I'm here today and we're going to be talking about surds. S-U-R-D-S. Surds, or basically what you understand by square root. When you see this symbol, it means square root. So that's surd. It's a special kind of topic in mathematics, but we understand it to be the square root of a number. And we have different kinds of surds. We have rational and irrational surds. Okay? When a surd is rational, or more or less, it's carrying a perfect number, then it can be rationalized. That's why we call it a rational surd. For example, the square root of 4, you all know, is 2. So, this is a rational surd. I don't even need to stress myself. I just know that the square root of 4 is 2. 4 is a perfect number. The square root of 16 is 4. What about the square root of 2? It becomes an irrational number. Irrational. Okay? And so, it might require that I have to punch my calculator to find out, which is, of course, is 1.414. Now, for this topic, we do not need to do this, except if we're required in some particular kind of questions. Most of the time, under this topic, in learning to simplify surds, you may, and most of the time, be required to just leave your answer in a surdic expression. Now, the number under the square root sign is called a radicand. Let me write that for you. The radicand. So the radicand of this surd is 2. That is the number under the square root sign is 2. So the radicand of this surd is 2. So basically, instead of saying square root of 2, we just say surd 2. Alright. Most of us must have learned a few things in algebra, in handling algebra. In my next video, as I would like you to, come up to watch, I'll be handling expression in algebra. So just basically in algebra, we've learned that x plus x is equal to 2x. These are like terms. The same way, if I have surd 2 plus surd 2, it is equal to 2 surd 2. So these are like surds. It's called what? Like surds. Just like you have these two as like terms. Now you know that unlike terms cannot add. Just like you cannot add A plus B, you cannot also add surd 2 with surd 3. You have to leave it like this. These are unlike surds. Unlike surds cannot add. Just like unlike terms cannot add. Like surds can add. So basically, we're going to be looking at how do we add surds. I can have a question like this. For example, you are asked to add surd 2 plus 2 surd 3 plus 3 surd 2 plus 5 surd 3. If you look at what we have, the expression we have on the board here, we have like surds and we have unlike surds. The like surds here are, you collect the like surds. Just like you collect like terms to add or subtract in algebra, you collect like surds. So I'm going to be collecting the like surds. I have surd 2 plus 3 surd 2. And then the other like surds, which is unlike with surd 2, is 2 surd 3 plus 5 surd 3. So these two go together as like surds. These other two go together as like surds. And I'm going to be adding it. Just imagine you are adding x plus 3x. That is how you should view this. And then this is plus 2y plus 5y. That's exactly how you should view surds. If you can view surds like you are handling algebra, you won't have any problem with handling surds or solving surdic expressions. So this is like my x plus 3x. And x plus 3x is 4x. So surd 2 plus 3 surd 2 is 4 surd 2. Where did I get the 4 from? There's actually an invisible one here. So there's a coefficient of 1 with this sod 2. So the 1 plus 3 adds as 4, and I keep my sod 2 as sod 2. Plus 2 sod 3. This is like your 2y plus your 5y. The coefficients add, you keep your y the way it is. So the coefficient here is 2 plus 5, I have 7 sod 3. This is final answer. Why? This is sod 2, this is sod 3. They are unlike sods. They cannot add. You leave your final answer this way. But if you had your final answer as 4 sod 2 plus 7 sod 2, they can add. They are like sod because the radicand 2 is the same. So you can go ahead to have 11 sod 2. But in this case, this is where your final answer will be. Okay, so let's solve some questions in simplifying sods. I'm going to take an examination question. You find this kind of question in the exam, what do you do? So simplify. I have 5 sod 27 minus 3 sod 12 minus 4 sod 3. Now, there's what we call the basic form of a sod. Before I solve this particular question, I want to quickly remind you that we have the basic form of sods. What do I mean by that? What do I mean by the basic form? The form at which that sod is brought to such that you cannot go any further. For example, even in fraction, we have the basic form of a fraction, the simplest form or the lowest term. You have a fraction like this, let's say 16 over 20, and you are asked to simplify this fraction. It means reduce this fraction to its lowest term. In other words, divide until you can no longer divide. So, I can divide 16 by 4, I can divide 20 by 4. That's their common factor. So 4 go here 4 and 4 go into 25. Final answer 4 over 5. I have brought 16 over 20 to its basic form. I can no longer go beyond this point. So that's what I mean when I say sods can be brought to their basic form. So we're going to have to bring each of these sod expressions to their basic form. Let's look at the last expression. 4 sod 3. 4 sod 3 is already in its basic form. That means I cannot reduce sod 3 any further. It is an irrational expression. So we're going to leave it the way it is. Let's come to 5 sod 27. 27 is a multiple of 3. So I'm going to reduce 27 into two products. One which is a perfect square, the other one an irrational number. So I have 5 sod 9 times 3. 9 times 3 is my 27. But if you look at 9 and 3, one of them is a perfect square, which is 9. So we'll get back to that in a moment. Minus 3 sod, let's look at factors of 12, one of which should be a perfect square, that's 4. 4 times 3. And then minus 4 sod 3. Now, another thing I'll bring to our knowledge is that sods can be split. You can split a sod. For example, if I have sod AB, I'm sure you know AB is multiplying. So I have sod A times sod B. I can split sods this way. Sods can be split as long as it is multiplication. Sods can be split. So sod AB means sod A times sod B. So I'm going to split this sod here. I'm going to split sod 9 times 3. Watch me now. I'm going to have 5 times sod 9 times sod 3. I'll split it. Minus 3 into sod 4 times sod 3. Minus 4 sod 3. What I'm doing is that I'm gradually trying to bring each of these sodic expressions to their basic forms where they can add or subtract. As it is in the original question, you cannot add or subtract them. You have to bring each of these sorts to their basic forms. So, we can see here in the first expression that the square root of 9 is 3. So I have 5 into 3 times surd 3. Surd 3 is in its basic form. I have to leave it like that. Minus, bracket closes, minus 3 into, the square root of 4 is 2. 2 times surd 3. Bracket closes, minus 4 surd 3. You can gradually see that there is something common with all of them. Surd 3, surd 3, surd 3. That's the idea. Because we have gradually made them have a like surd. So, I'm now going to open the brackets. 5 times 3 is 15 surd 3. Minus 3 times 2 is 6 surd 3. Minus 4 surd 3. I have like surds across. Surd 3, surd 3, surd 3. So they are like surds. 15 surd 3 minus 6 surd 3 minus 4 surd 3. So it's possible to add or subtract them because they are like surds. So 15 surd 3 minus 6 surd 3. That gives me, what does that give me now? That gives me 9. 15 surd 3 minus 6 surd 3 minus 4 surd 3. Altogether, everything gives me 5 surd 3. Final answer. So we can see that surds can be added or subtracted. But if these radicants are not the same, please do not subtract or add them. If I have 15 surd 3 minus 6 surd 4 minus 4 surd 5, please, that will be your final answer. But because this is surd 3, surd 3, surd 3, they can be added or subtracted together because they are called like surds. Okay, so that's basically all about this particular question. And then we're going to take another example here. Okay, before we take this particular example, I want to talk about the conjugate surds. What do you mean by conjugate surds? Conjugate surds. In case you come across it in an exam situation. Anyway, for my next video, I'm going to be expatiating on conjugate surds, but I just want to introduce it to you. Conjugate surd, if you have an expression like this, A minus surd B, the conjugate surd of this expression is the same expression but with a different sign. So the conjugate of A minus surd B is A plus surd B. Anytime two conjugate surds multiply, it gives you a rational number. It gives you what? A rational number. So conjugate surds multiply to give you rational numbers. Okay, so let's take an example now. Let's take an example. We have an example which says that we should simplify 3 surd 15 times 2 surd 48 all over surd 32 times 4 surd 45. Okay, we're going to look at how to simplify because there are some things here that will eventually, by the time you reduce them to their basic forms, they will begin to cancel, both at the numerator and at the denominator. So I'm going to express each of these surds into their basic forms. Let's go. So we have 3 surd 15. 3 surd 15 is, I'm splitting the surd now. 3 times surd 15 is surd 5 times surd 3. That's my 15. Times 2. Surd 48. I have 16 times 3. In 48, you have 16 times 3. So that's 2 times surd 16 times surd 3. I've split it. So I now have surd 32. 32 is surd 16 times 2. So that is surd 16 times surd 2. This is my 32. Times 4 times 45 is surd 9 times surd 5. Surd 9 times surd 5. I have split the indices. The idea is to see what can divide both up and down. As you can see, surd 5 will cancel surd 5. Surd 16 will cancel surd 16. And surd 3 times surd 3 is surd 9. Surd 3 will cancel surd 9. Okay, so let's go. I'm left with, what do I have left? I have 3 times 2. And the numerator, always remember to collect what you have left. You don't leave anything out. I have surd 2 times 4. I can still divide further. 2 go here, 1. 2 go here, 2. So I'm left with 3 over surd 2 times 2 is 2 surd 2. Please do not write it as surd 2, 2. Please, we don't write like this in surd. The number is a coefficient of the surd. Just like we don't write x2 in algebra, we write 2x. The same way for surd, we don't write surd 2, 2, we write 2 surd 2. Now, in an examination situation, if you leave your final answer like this, you will lose some marks. 3 over 2 surd 2, you cannot leave your final answer like this because the denominator cannot have an irrational expression. Your denominator in surd must be a rational number, that is a whole number, an integer, positive or negative. It cannot be a surdic expression. So we will need to what? Rationalize the denominator. How do we do that? So let's go. I have 3 over 2 surd 2 as the answer which I arrived at here. And then to rationalize this expression, I'm going to multiply the numerator by the surd 2 at the denominator and the denominator by the same surd 2. This is how to rationalize a fraction when there's a surdic expression at the denominator. So let's go. 3 times surd 2 gives me 3 surd 2 over. The idea is to rationalize the denominator. So I have 2 times surd 2 times surd 2. Let me show you a typical way of what you're looking at. You have 2 times surd 4. Actually, surd 2 times surd 2 is surd 4. Remember, 4 is a perfect square. So we're left with what? 3 surd 2 over 2 times square root of 4 is 2. You can see that it has become a rational denominator. So we have this is equal to 3 surd 2 over 4. You can now leave your final answer like this. You cannot leave your final answer like this. You can see how many steps it took us to rationalize the denominator. In the examination, if you leave it like this, you can lose 2 or 3 marks. This kind of answer can also be presented in the multiple choice in the OBJ. And if you see an answer like this, it's a distractor. You will lose marks. So you have to take it further, 2-3 more steps to rationalize the denominator. The denominator should be a rational number, a whole number, an integer, negative or positive. You cannot leave your denominator as a surdic expression. I guess that's simple to remember, and it's not as difficult as it appears. Okay, so we're going to take one more question. I want to multiply a surdic expression. You are given a question like this, for instance, and you are asked to find the square of 3 minus surd 2. Find the square of 3 minus surd 2. Please, in the examination, do not do this. 3 squared minus surd 2 squared. That's not what they mean. A lot of candidates do this and they miss it out. Please, 3 minus surd 2 is together. It's a binomial. It's bound by the negative sign there. So, please, what do? It's just like saying, find the square of a minus x. You are supposed to square everything. So, the same way too, for the surdic expression, it means 3 minus surd 2 all squared, all raised to the power of 2. And then you expand like you do in algebra. 3 minus surd 2 into 3 minus surd 2. And then you begin to expand. 3 times 3 is 9. 3 times minus surd 2 is minus 3 surd 2. Minus surd 2 times 3, like I said, we don't write minus surd 2, 3. We write minus 3 surd 2. And then minus times minus is plus. Surd 2 times surd 2. Like surds gives you a rational number, which is 2. How? Surd 2 times surd 2 is surd 4. Square root of 4 is 2. So I don't need to write square root of 4. Surd 2 times surd 2 is 2. Alright. So I collect like terms. I have 9 plus 2, which is 11. Minus in addition is minus. 3 plus 3 is 6. Surd 2, like surds. Final answer. So minus 3 surd 2 minus 3 surd 2 is minus 6 surd 2. So the final answer is 11 minus 6 surd 2. So this is how far we can go for surds today. I hope you enjoyed the class. In my next class, I'll be dealing with conjugate surds, how to multiply conjugate surds, how to rationalize a surdic expression that has a surd at the denominator. And I hope you're going to be joining me in that video. Thank you for watching my video. I'll see you in my next video.